Today's video is going to be an introduction to matrices for A-level further maths, talking about addition, subtraction and simple multiplication. So first of all, a matrix is a grid of numbers or elements of size m by n. Now what does this mean? It means we have some sort of grid, as you can see the one I'm drawing here, and it's filled with numbers in certain spaces, and as you can see there's 4 columns of numbers here and 3 rows all of different numbers, and we label the rows m and the columns n. So this matrix here we can see is a 3 by 4 matrix. A vector, then it seems right to define, are matrices of size m by 1. So this is where there is just one column, such as this one, which is a 3 by 1 matrix or 3 by 1 vector. So what will we actually use matrices for? Well, the first thing is that they can do multiple calculations at once because we have multiple numbers just in one grid, and hence this makes them useful for solving simultaneous equations. And there's going to be much more things along the line, such as transformations in a video to come. So, addition and subtraction of matrices. Matrices need to have the same dimension, that's the m by n size, to be able to perform addition and subtraction between the two. And why is this? It's because we have to add or subtract the corresponding elements in their matrices. So we'll take this example. So we have 132,046, add 520,115. First of all, we want to add the 1 and 5, and that's going to go in the first gap of our solution matrix. Then 3 add 2, and so on. 2 add 0, and then we start our next row. 0 add 1, 4 add 1, and 6 add 5. So our final answer is here, 6521511. So it's just simple addition, but remembering to keep in the corresponding elements of the two matrices. And then subtraction works in a similar way. So I'm just going to use the same matrices here to highlight how to subtract between them. So 132 again, 046 minus 520,115. 1 minus 5, 3 minus 2, 2 minus 0, 0 minus 1, 4 minus 1, and 6 minus 5. And as you can see, it's just the corresponding elements in their places being taken away from each other. And this is the first time as well that I'm showing you can have a negative number in a matrix. We cannot add matrices of different dimensions. And I'm just going to show you a quick example of where we cannot. So 2, 1, add 3, 4, 0, 1, 5, 2. Obviously we have 2 add 3 there, but we can't do any others. We cannot add corresponding elements because there just isn't. So now we're going to look at multiplication of square matrices. Now square matrices aren't written with a square, I was just saving some space. But a square matrix is one where the m and n are the same. So if it's 2 rows across, it's 2 rows, 2 rows, 2 columns. The number of columns equals the number of rows. E.g., this one is ABCD and a 2 by 2 square matrix. Then we have a numbered matrix, which is of size 3 by 3. And this can be any size for n. Just needs to be the same number of columns and the same number of rows. So now we're going to start maybe a tricky part of how do we multiply 2 square matrices together. I'm just going to start with 2 by 2 and some algebra. So the first thing is that for the first matrix we have to multiply across and then down by the column of the second matrix. And then for our next element, again across on that first line, but then with our second column. And as you can see here, the first arrow I've drawn is AP plus BR, and that's what goes in our first element of the 2 by 2 solution matrix. Then we get AQ plus BS, and hopefully the arrows are highlighting which I'm multiplying with, CP plus DR, and then CQ plus DS. And it looks very complicated. That diagram is messy, so hopefully once I show it with some numbers it becomes a bit clearer, and also with practice this will become clearer too. So here we have 4231 multiplied by 1103. So I'm just going to follow across in the first row and then down the first column, and that looks a bit like a B, so I'm just going to rub that out, make it a bit neater. So we get 4 times 1 add 2 times 0, and that's the arrows just show what calculation I've done there. Then in our next element along we get 4 times 1 add 2 times 3. Then we move to our second row of the first matrix and get 3 times 1 add 1 times 0, and then 3 times 1 add 1 times 3. And so I'm just going to add these together. And our solution matrix is 4, 10, 3, 6. So in matrix 1, this is key to know, in matrix 1 you always go across first until you've multiplied by all the columns down of matrix 2, and then once you've multiplied by all the columns down you move to the second row of matrix 1 and multiply down again. What this means is that the order in which you multiply the matrices together is important. And I'm just going to highlight this by seeing what happens if we do 1103 multiplied by 4231. Will we get the same answer? You may already be seeing that it doesn't look like it. We get 1 times 4 add 1 times 3, then 1 times 2 add 1 times 1, 0 times 4 add 3 times 3, and 0 times 2 add 3 times 1. Which gives us this final matrix of 7393, which if we check with the answer we got before, it's not the same. So this means that the order in which we multiply the matrices together matters. And this leads into the idea of commutativity, which I cannot say, commutativity. There we go. So if we have some matrix A and we multiply it by B, as I'm just going to write out here, that does not mean that B times A equals AB, generally. In some cases you may find that it does, but in most cases you will find that the order does matter between them. So it's always important to remember which matrix you're applying to the second matrix. The first matrix is normally the one that you are applying to whatever second matrix that you have. Whichever's first in your multiplication chain does matter. And now we're just going to end the video with 3 by 3 matrix multiplication. And this works in a similar way, well I mean it works in the same way to 2 by 2 matrix multiplication, but it's just an extra row and column, so it can be a little annoying to go through. And it can get very messy quickly with the arrows, so you just need to remember where you are with it and keep an eye on your signs. Here I'm just doing all positive numbers, but it's very easy to lose track of whether you're timesing 2 minuses together, etc. So the first row, we need to multiply 3 once with the first column of the second matrix, then the first row again with the second column, and then again with the third column. And I'm just filling out what we get from these. And that fills our first row of our solution matrix, as you can see. So now we move on to the second row and multiply by the first column, as you can see. I have skipped the arrows for now because hopefully it is seeming clearer that it's just an addition from the 2 by 2 matrix. We're just making it a little bit more complicated, but it's the same idea of simple multiplications between the rows of the first matrix with the columns of the second. And our final matrix, you can pause the video here if you'd worked on it yourself to see if you get the same. and just doing simple addition, which is very long-winded with these matrices, but there we get our final solution matrix, which is 22, 33, 23, 8, 12, 11, 13, 18 and 8. Thank you very much for watching, and click below for more videos. Bye!